Welcome back to the workshop. I've made myself a cheat sheet here because I always forget to say something. I'll try and get through it quickly. I'm amazed at the number of subscribers that have signed up. It's coming up to 400 now, and it was only a few weeks ago that I was hoping to reach 100, so really pleased about that. Next thing is stickers. Matt Cremona is a pretty famous YouTuber. He sent me a couple of stickers. They'll go on the board. And Kevin from Machine NZ, he's got an excellent channel. They both have. Kevin's just done a couple of videos on DROs, which is very interesting to me because I've got a DRO to fit onto my mill soon. I know people are waiting for that. It'll happen soon. Just want to get this bandsaw done first. So stickers. And if anybody wants a sticker, email me to this address, email me your postal address and your name, and I'll get some in the post to you. So stuff that I've been up to in the meantime. Got those machine bases done, and I've used them a couple of times now and they work a treat. Very happy with those. Next piece is I've been playing with worm gears. You can see a bunch of old, totally worn out worm gears. Some of these have been given to me by friends. Some I've harvested out of old radio equipment and all that kind of thing. And the best one I've had to work with was given to me by a friend called Tony. It's a 25 tooth with mild wear, but we didn't know what module or DP it was, and using taking direct measurements and working backwards from the standard sizes that you can find, I turned a worm that fits it. This was quite interesting because I had to make a pitch that was completely non-standard on my lathe. I wrote a little bit of software that can take all my gearbox ratios and all my change gears, and it can basically spit out all the options. It just brute forces through all the options and finds the one that's closest to what you're looking for. I'll show you a little screen grab of that, and you'll be able to see how it works. I also made a spreadsheet that has some input parameters, like you can tell it the worm gear module, and you can tell it your diameter and all that kind of stuff, and it will work out your tool dimensions. So you basically create something very much like an Acme tool, depending on your pressure angles and all sorts of other things. That's in the spreadsheet. I'll leave a link to that as well in case you're interested. Basically, you plug in a few basic numbers and it spits out all the interesting stuff. And the reason I'm into worm gears at the moment and worm wheels is that somewhere along the line I need to come up with a dividing head type solution, maybe even with sort of rotary table functions. Not fully decided yet. But there is a very excellent design by Harold Hall, and it uses lathe change gears. Now I've got a stack of change gears with my lathe. The only problem is Harold's design is really designed for a Myford ML7, which has a 7-inch swing, which is about 175 millimeters. My lathe is a little bit bigger, and the change gears on the end are a bit bigger as well. Myfords use a 20 DP gear size and mine uses a 16. So everything's 25% bigger. Each linear dimension is 25% bigger. So what I'll do is I'll scale up Harold's plans. I'll use the change gears from my lathe, and I'll turn a worm to suit the 16 DP pitch, and I should have quite a useful tool at the end of it. Not sure when that will happen. I've got these other things to finish first, but it's in the back of my mind. I had some questions about mill vise. The jaws in there were shimmed, and I haven't had a chance to look at that yet. What I'm going to do is clear off the mill table, because it's a horizontal surface. It gets covered in junk in between projects. At least the floor's not covered in junk. So what I'll do is I'll clean that off, mount up the mill vise again, stick an indicator in the collet or on the spindle, and measure how true it is to the sort of axes of the mill. So I'll move the table up and down and see what deviation I get, any out of plumb or out of parallel, any twist or whatever. Yeah, that's all the stuff I've been up to. I've acquired a few bits and bobs. So in here is a little cheap tachometer with Hall effect sensor. This later on will be plumbed into my mill spindle, and because I've got the VFD and a gearbox between the VFD and the spindle, I don't ever know quite what speed my spindle's running at. So this will be attached to the spindle, and this will be built into a control panel of sorts that's got some broken out switches, knobs and readouts from the VFD screen. And that will sit just below the DRO screen that's not installed yet, but it's all coming. And that's going to be part of it. Next thing was I found a deal locally on a really nice Moore and Wright fine pitch micrometer, digital micrometer. I've got some micrometers, and I've got one that goes down to microns, but it's a vernier style, and I can't convert the dimensions very easily on it. Whereas this one, really cool. It allows me to more easily work with my metric dimensions that I want to use on the lathe and mill that I've got that are done in Imperial. So that'll be handy. This is a ER-40 12-sided collet block. So I'm quite excited about this. I haven't used it yet. It's still covered in the grease that it comes in. I use ER-40 collets on the mill, and I've got the full set of metric collets. They're a high quality set from CTC, and they'll go in here beautifully. And this 12-sided design is what's unique about these style of collet blocks. You can get your 2s and 4s divisions like you can with a square collet block. You can also get your 3s and 6s like you can with a 6-sided, and you can get them all with one block. The other thing is the body is actually quite a bit bigger than you get on the square and hex ones, and that means that you're not limited to hanging this nut out of the side of your vise or blocking this up on 1, 2, 3 blocks on the mill table. You can actually stand this on its end or on its flat, on its side, with no problems. And you do have to have a certain size of vise, because you need to be able to reach up. If this is flat on the base of the vise, you need to be able to reach up at least to this point here, otherwise it's not held properly. It came with a bearing nut on the front, which I've never used. That's going to be interesting, because apparently that allows for a little bit more accuracy and it requires a little bit less torque. So looking forward to using that. Well, I think that's about it. Bandsaw is coming up next, and then mill DRO after that. And I'm a terrible procrastinator, so I may get some small things done in the meantime. Thanks for tuning in. See ya.